analogous or an analog for what you have buried in the area that you're trying to evaluate. And the fact that you can go and look at the outcrop, and the fact that you can actually measure things directly from the outcrop, whether it's with a ruler or a mean permeameter, is useful. Okay? So that's another aspect you might bring into that question. You might also have a brief discussion of the idea of outcrop analogues. Any other questions about that question? No? Right, next. Yeah.
In reservoir modelling, what's the Monte Carlo technique?
Monte Carlo technique is a type of modelling where you do lots and lots of what we call stochastic simulations in order to understand how something works. Right? So, imagine you've got a situation, let's just think about it in terms of stowing. Who can tell me, is that supposed to stay down? Who can tell me the Stoic equation? Given your extensive revision and your razor sharp, intellectually keen minds.
I'm not part of it.
The gross rock volume times
Porosity
times oil saturation, hydrocarbon saturation.
times net to gross.
Yeah, net gross over formation filling factor.
Stoic.
I think so.
Is it gross rock volume first of all?
I could have done better. Cool.
Oh, there's a knife. He's got a cake on it. Hang on, let me just go and get a pen. I won't be a minute.
I'll probably need a knife instead of a pen right now.
Was question 3 his first question?
Someone wouldn't know about question 3.
That was his first answer. Oh my god.
I just want to ask him about basic modelling. Like, is it just what he has on his lecture?
What?
You know, basic modelling question. The 1D basic modelling. Discuss rule of 1D. But he only has one slide on 1D basic modelling. Right? He wants the whole question on that versus 3D basic modelling. I can write 2 paragraphs at max. Oh shit,
Oh.
Traffic is so good. Traffic is so good.
Today I had a nice car race me at least.
Yeah, that's good. Like,
I raced it, yeah?
yeah.
I went past like a good 100 meters of it. I'm like, dude, I know you can go faster in your car because it was like a sports version of that car.
Yeah.
And then I got stuck in a bit of traffic. All I see is that guy got pissed off, I think, with the traffic. So he went to the fast lane and just belted it across. I'm just like, yeah, that's what I'm talking about. But did you leave at what, 6 in the morning?
No, I got late, so I left at 7:15.
But you still got
I
here
knew I'd
time.
get traffic. And what?
Back.
It must be grab. Oh no, sorry, I've got
It's behind your left. What is it? What's the actual thing?
That's what we said.
Right.
Go on, Ian.
Saturation of hydrocarbons. And then when I go
No, I think I'm fine for picture.
Right. Stoic then is
Just read through notes again.
rock volume, and then what?
Times net to gross.
Times net to gross times porosity, which is what single we normally use for that, times
hydrocarbon saturation.
That's what we call it, does it? Times. Anything else? Is that it? There's another thing, isn't there? These. One over the formation factor. Okay? So that's gross rock volume. Now,
Because he said yeah.
you're trying to calculate
No, he could go that deep.
what the gross rock volume is in a particular case. The problem is you don't know exact values for any of these things. Okay? You don't know the exact gross rock volume. You can estimate it, but each estimate you make has an uncertainty. So you can say it's between 1 and 2 times 10 to the 6 meters cubed. Okay? And the net to gross, similarly, you know, is between 70 and 80%. The porosity, 20 to 25%, and so on. Okay? So the point is, for each of these parameters, there's a range of possible values to use. Now, what a Monte Carlo simulation does, and it's really simple, but actually very, very clever and effective, is it says, well, okay, I'm going to calculate the stoic 1,000 times, right? And for each calculation, I'm going to guess a value. So I'm going to have one calculation that assumes 1.1 times 10 to the 6 meters cubed, and a net to gross of 72%, and a porosity of 25%, and so on. I'm going to calculate the stoic, and I'm going to remember the result, and then I'm going to go back, and I'm going to repeat the process, and I'm going to make different guesses each time. Okay? What you would end up with would be what we call a probability density function for stoic, right? And this would be frequency, right? So in other words, frequency of occurrence. And the Monte Carlo method would give you the mean and the sort of tail, including the standard deviation, based on the guesses that you make for these parameters. And the sample size here, the number of calculations that it did will be, say, 1,000. All right? So that's a Monte Carlo method. It's basically a way of dealing with uncertainty in the parameters that you have in any kind of quantitative calculation. If you're interested, how do you think we have 300 to 400 applications for our petroleum MSc every year, right? How do you think we actually make sure that we get 35 students? Because we can't just offer 35 places because some of those students won't come. How do you think we do it? We actually do it with a Monte Carlo simulation, whereby we say this student has got a 0.9 probability of joining the course, this student has got a 0.1 probability of joining the course, and then based on the offers that we've made, we calculate the mean number of students we expect on the course using a very similar kind of Monte Carlo technique. Okay. But in the oil industry, stoic for any subsurface reservoir is probably going to be estimated using the Monte Carlo type method. So what other techniques can you think this, do you think this might apply to? What other methods might use Monte Carlo methods? Anything else? Same basic thing. You could run. The problem with dynamic models is they tend to be quite slow to run sometimes, but you could run 100 dynamic models with varying parameters and see what the resulting production history was out of a particular well, couldn't you? Okay, so that's Monte Carlo. Any questions related to that? You all understand the difference between static and dynamic modelling? Yeah? You know what a static reservoir model is? You could write an explanation of what a static reservoir model is, what a dynamic reservoir model is. I can't remember what the questions are on the paper this year because I wrote it ages ago, but that's one that often comes up. Any other questions? Other things that we need to go through? Else this is going to be a very short revision session. Number 5. Question 5 on this paper. Right. The basic methods of 1D basin modelling. What is 1D basin modelling? What does 1D stand for, first of all? One-dimensional, but what does that mean in this context? What is it we're saying is one-dimensional? Are you one-dimensional? Anybody one-dimensional? No? Anybody two-dimensional? Any of you ever read a book called, I think it's called Triangle World? Something like this. It's about a two-dimensional world populated by triangles and circles and so on. Quite a freaky science fiction book written by some Victorian chappie who was obviously a very early discoverer of LSD or something similar. It's a very strange book. But you're not two-dimensional, right? You're three-dimensional. Yes? So what is a one-dimensional basin model? What do you think the dimension might be? Have a wild, stabbing guess. What do you think the dimension might be in a one-dimensional basin model? A line, yeah, it will be. By definition, it will be a line because a one-dimensional system can only be a line. Do you all understand this point, right? If you say something is one-dimensional, what you're basically saying is you can specify it using one value only, and that would be the distance along a line from the point of origin to the point X. If you've got the value of X, you have perfectly specified your one-dimensional system. If it's three-dimensional, you need X, Y, Z, don't you, to specify where something is, right? So we're dealing with a one-dimensional basin model, but what do you think that one dimension might represent in a one-dimensional basin model? Sorry? Yes, very good. He shoots, he scores. So we've got basically depth, which we typically refer to as Z. So your one dimension in a one-dimensional basin model is depth. Why does depth matter in a basin model?
Very
basin, for that matter. Yes, this is. That's like saying, Royal Holloway is quite green. It's a vague statement. You're along the right lines, but can you be more specific? Since you are doing all the work this morning, you might as well carry on. Which particular aspect of the petroleum system are we most interested in when we're doing basin modelling? What's the first thing that we are considering? Source rock. Right, source rock. And what must happen to the source rock for it to be a viable petroleum system? Why does it have to be at a certain depth?
So it could cook.
Right, because it needs to be at a certain temperature. Temperature tends to increase with depth according to the geothermal gradient. So if the source rock is at the correct depth, not too shallow, not too deep, it'll be at the right temperature to generate oil and gas. What is the approximate temperature range of the oil window? A fact that you should have at your fingertips. And that would be gas. 150 would be the starting temperature for generating gas, pretty much. Probably 100, you're getting warmer.
120.
Cooler and therefore getting warmer. 60 to, good. About 60 degrees to 120 degrees. Now, you're not going to get much oil being generated at 60 degrees. By the time you get to 80 degrees centigrade, oil will really have kicked off and be charging. So you're talking about 60 to 120 degrees for the oil window. Can you all draw an approximate graph showing how oil expulsion or oil production from a source rock relates to temperature and depth? If not, you should probably revise that. I don't know whether it's on the exam. I'm not saying, I think you just need to know it. Okay? So for 1D basin modelling, we're interested in depth because we're interested in temperature, because we're interested in how the source rock might mature. So let's have a look at that question again. It says, the basic methods of 1D basin modelling. So given what I have just said, what do you think might be the basic method of 1D basin modelling? What do you actually model? In 1D basin modelling?
Burial history?
The thermal history is pretty much it. The thermal history of what? The thermal history of a tulip?
No.
No. The
Source
thermal
rock.
history of
Source rock.
the source rock. So basically, the 1D basin model reconstructs the deposition and burial history of a source rock in order to predict if and when that source rock will have expelled hydrocarbons. Right? Now, one very, very important point. Is a source rock the same as a reservoir rock? No. Every year I tell you this, and every year I think they can't possibly be that stupid. Every year, at least one person on this exam confuses source rock and reservoir rock. Right? So don't be that one person. Do not be that person. Be better than that person. Do not make that mistake. Right? Source rock is the organic rich facies that generates the hydrocarbons to begin with. The reservoir rock is where they end up before we extract them to use them. So you might say that the reservoir rock is the source of the hydrocarbons we use. In some senses that is true. That's where we extract the hydrocarbons from. But that is not the same thing as it being a source rock. If you say in any one of your question answers, if you make it appear that you do not understand that distinction, you will be rapidly approaching the 0 mark for that question because it's such a fundamental misunderstanding. Okay? So don't make that mistake. So back to basin modelling then. You've got a source rock, it's being buried. And you're trying to decide if and when it expels hydrocarbons. So what are you effectively doing? What kind of calculation does a 1D basin model do? What do you think it calculates? Is this a numerical model? Right, so it's calculating something. It will try to calculate the volume of hydrocarbons released, but that's actually quite complicated. What simpler thing can it calculate, given standard sort of information about geothermal gradients and so on?
The temperature,
Temperature with depth. It'll calculate the depth of the source rock as it is buried, and it will calculate the temperature, therefore, that source rock is at. And it'll keep track of how long the source rock has been at a particular temperature. based on those things, it might make a simple prediction of oil or gas generation. Okay? So if you can make those points, if you can actually draw some diagrams, because this question number 5 is a classic where you need to actually draw some diagrams, then you will be fine. What kind of diagram would you draw? What would be the classic diagram to draw in this question? What would you draw? Sorry? No, I don't think so. I would draw a basin. I'd draw something like this. That's time. That's depth. What do we call this kind of plot? Do you remember this from your notes? These are layers of rock. This is your source rock down here. This would be like Cretaceous, Jurassic, and so on. What do we call this kind of plot? You've got them in your notes, you've got them in the textbook. If you've read anything so far about basin modelling, you should have seen this diagram. This is a burial history plot. So I would want to see an example, even just a cartoon example of a burial history plot in this answer. Okay? And then finally, the advantages and disadvantages of 1D basin modelling versus 3D basin modelling. What's the key the key thing that you can calculate in a 3D basin model that you cannot calculate in a 1D basin model? Sorry? No, time is in a 1D model. Time is on the x-axis in that 1D model there.
Is it migration?
Yeah, migration. Good. Oil and gas migration, because you need at least a 2D model for that. Because if you think about it, unless the oil migrates perfectly vertically, your 1D model, let me just make this completely clear. Your 1D model is dealing with a single point and depth, right? And the depth might vary through time, but basically it's one-dimensional, whereas a 3D model is dealing with x, y, and z. And so you could have a source rock down here, you could have a reservoir up there, and it'll basically model the way oil migrates from the source rock into the reservoir in 3 dimensions. But you can't really, the only migration you could model here would be completely vertical migration, which is not particularly realistic. Okay. You could just say that when the source rock got down to this depth here, it expelled hydrocarbons vertically upwards. That's all you could do in 1 dimension. Alright? So that's the key distinction between 1D and 3D. Which do you think is quickest to calculate, 1-dimensional or 3-dimensional basin model? Because there's far fewer calculations to do for a 1D model. A 3D model can take a week or so on a supercomputer to calculate if it's a particularly complicated example. Alright? What else? Anything else people have come across that they don't understand while they've been revising? Yeah.
Can you go over the size of the question from number 2?
Yeah, okay. Identify a seafloor, sea surface multiple on this section. It's got the section here.
It's on the one we
Yeah, it's not there, is it? No, I don't think it's.
The one that's on the Moodle pad is.
Go back. Where? Here.
If you go onto Moodle,
Yeah, I'm on Google.
not onto the page with all the lectures and stuff,
Yeah.
and then down, they just put, if you go up to a bit more, yeah, paper there, that has it on.
Oh. Sorry, I was just thinking wrong thing. Right, cool. Yes, there you go. Right. Right, now, where's the, do you know what a multiple is? What is a multiple? How does a multiple work? Come on, somebody tell me. What is on seismic data, what is a multiple? Sorry?
It's like a reflection of the layer on top. And
Sorry, Chris, say again, I'm coughing.
it reflects because of like, as you have the changes between it can bounce back down and up and stuff.
Yes. That is
That's the diagram.
yeah, a diagram. The diagram looks like this. If you, these boards are a nightmare. If you have the sea surface and something below sea level, and you have a source here, and you have your array of detectors here, right? What you want to happen is you want the sound energy to go down and be reflected and actually record here, okay? But sometimes what happens is the sound energy goes down, comes back, goes down, and then comes back again, okay? So it follows a much more, well, basically, what's the difference in terms of the two-way travel time between the one that goes direct and the one that goes like that? What effect is that going to have on two-way travel time? It's going to double the distance, therefore it's going to double the two-way travel time, right? So when you try and reconstruct the image of this surface, instead, the first trace will make it appear here, but the second route for the energy will make it appear down here, basically at twice the depth. So this will be at depth D, this will be at depth 2D. Right? This is a multiple. It's an artifact of the way that you tried to collect the data. It's not real. Alright? So where on that seismic section
Where did we take
is,
the multiple was?
can you see a seabed multiple?
Didn't we mark it?
Any volunteers? I'm going to just leave you to look at it. You should now be able to, knowing what you know, you should be able to work out where it is. Right, basically, it looks like
That's
the
no, it might
seabed,
be this one. Okay. It might be
but
that one.
it's,
Actually, I'm not sure.
so it should be about twice the depth
It might be
of the
that one.
seabed. It's actually good. You might need to print it out and look at it, maybe it's not clear on this screen.
Have a look at that.
Sorry?
Right click. That's what it is. as well. Could be that one as well. 3 possible.
I think it's probably this stuff down here.
Okay. Hmm?
But that's quite a hard question actually. It's something I don't think something on paper this time is as hard as that in terms of seismic. From what I can remember. Anything else from that question? What else did you want to know? Yeah.
One of the questions about what was it asked, how can you minimize them? How can you minimize them, like the processing?
Right.
It's quite understanding.
So you basically, I can't remember the name of the technique, there's a filtering technique that you use that is actually good for removing multiples, but I can't remember the name of the filtering, but you can look it up. You would have done loads of stuff on that in your second year geophysics notes, so if you refer to those, there'll be more information you need. I can't remember what it's called. Anything else? Yeah.
It was related to this one. This is a question about something about the end of what is saying why reflection goes up. So I can't remember the question was. Might be that one.
It's over processing.
I don't think it's. Why does the strong reflector, which dips to the right and reaches for the
Just say it.
sharp
Please just say it.
Because there's a high chance we're wrong.
What do you think is causing that?
Just over migration.
Sorry?
Just over migration when they pick the velocity too fast.
Yeah, basically, it's a migration smile, isn't it? It's been wrongly migrated. Okay? So if you look up migration smiles,
Yes,
you
we
will
got
learn more
please.
you need to know. It's probably better for you to read about it from the textbook here in Brooks or even maybe Glorious and Swarbrick, I'm not sure whether it's in there, or your second year notes. Just look up
It's not in the
migration
thing.
smiles. You'll get the information you need. Anything else? Any other questions that have arisen during your revision?
Yeah, I think so.
Oh, yeah. Would there be, is there likely to be a question? Describe the geological history of the petroleum system that you've studied. You can actually study one specifically in lectures, but
I don't think so on this year's paper, but I can't remember what's on there. You should, I think, as a matter of course for the revision, be able to give at least a few basic facts about a particular petroleum system. Even if you're not asked directly in the question, it's good to know so that you can introduce it as an example. Right? Because remember, to get good marks, like 70 and above first class degree marks and so on, you need to be able to give evidence of additional reading. One way that you could do that would be for an example of a petroleum system that you've learned something about that we didn't directly cover in the course. Okay? You're going to ask something.
Yeah, on the fault sealing questions, there's always, at the end of it, it says how do you identify whether a fault will be sealing or not?
Right.
From, I'm assuming, data, subsurface data.
Right.
What are the different methods you can use for that?
Right. What did we do in class? What methods did we do in class? There were two really, weren't there? Sorry? Yeah. Clay smear is one mechanism that can seal a fault. What was the other? Shale gouge. So any kind of prediction is going to be based on an understanding of those two mechanisms and trying to determine whether either of those mechanisms has operated. Okay? Well, that's not true. One way to predict will be based on those two mechanisms, right? And there's all in your notes, it explains how you do that. You basically look at the displacement on the fault, you look at the thickness of shale units, and you see how far, therefore, they may have been smeared out along the fault, right? So you can look at that from your notes. What other technique, though, did we talk about? Do you remember fault juxtaposition diagrams? I think they're called Allen diagrams, actually, aren't they? Where you basically you plot, looking through the fault plane, you plot the reservoir units on one side and the reservoir unit and seal units on the other, and you see how they're juxtaposed, you see how they're aligned next to each other, and if they're in contact across the fault, does that mean it's more or less likely to seal? The reservoir units are in contact across the fault, less likely to seal. If the reservoir units have all been juxtaposed against shale or sealing units, simply by the fault movement, then it's more likely to be sealing. So, for example, just to draw you a very small sketch, here's a fault.
Reading for the rest of the day. It's easier one. Just gotta learn it now. It's so simple.
If the fault offset
It's got to remember a lot better.
has
It's saying
produced
that, it's
something
okay,
like
actually.
that,
I'm enjoying it now.
that fault is effectively sealing, assuming that these are reservoir units and this is seal. Right? Because you can basically trap hydrocarbons in here and in here because the other side of the fault is sealed. Okay? If the situation was slightly different and you had something like this, that fault is effectively not sealing because it's basically juxtaposed this reservoir unit against this reservoir unit. Hydrocarbons could just flow all the way through. Okay? So, in overview, there's two aspects to this. There's what happens on the fault plane itself. Is that surface a barrier or a conduit for flow? That's to do with fault seal, clay smear, shale gouge and so on. There is also the issue of how the displacement on the fault juxtaposes permeable and impermeable layers. Right? If you handle those two aspects, you will have basically dealt with a fault seal prediction. Okay? Yeah.
How much do you want us to write back on that question?
Well, you've got 2 hours, you've got to answer 3 questions, so that means about 40 minutes per question. What I like is carefully thought through, well-structured, logical questions that focus, answers that focus on the question. What I do not like is verbal diarrhea, where you regurgitate everything you know that you think may be vaguely related with the question in one great big vomit all over the exam script. Right? That will not get you high marks. Basically, if you are wondering to yourself whether something is relevant to the answer, and you're just putting it down because you're at that point desperate, that's not going to help very much. 2 pages of bullet point and diagrams that focus on the question and answer it part by part would be brilliant, with examples, evidence of external reading. That'll get you a 2-1 or a first class mark. Okay? 3 pages of prose which meanders in and out of the subject, most of which is irrelevant, that's not going to get you a high mark. Right? So it's not just how much you write, it's very much what you write. Bullet points and diagrams are great because actually it's much easier to mark. Right? It says, I'm not wasting my time writing Tolstoy's War and Peace, I'm just telling you what you need to know in order to answer this question. Right? So I think you should be able to do that for each question in half an hour, assuming that the stuff's all, at your fingertips. which gives you then a bit of time to think about which questions you're going to answer and plan the answers. It's definitely a good idea before you answer any of the questions, even if you just do this mentally, go through what you know, go through what your answer is going to be. You don't want to get to the last bit of the question and then suddenly think, oh my goodness, I don't actually know anything about this bit. Alright? In terms of answering questions, what should you do first? Worst question first or best? Probably good to do the best answer first, but what must you be careful of if you do that?
Not killing time.
Don't take all of your time answering that question, right? So I would basically, when I start answering the question, I'd look at my watch, I'd say 40 minutes from now means time X, and I would stop at time X. And I would move on to the next question. Alright? So time management is key. So does that answer your question? Anything else? Yeah.
It's not a particular question here, but I've read online and stuff, there's various sort of definitions for play.
Yeah.
Is a play used to just describe the group of prospects, or is it just to describe the whole sort of just similar geological?
Yeah, the latter. Play is something that is actually quite difficult to define right now, which means if there's a question on that is an opportunity for you to do what? What are we looking for to give you high marks in your answers? What are we looking for in being able to do? Stand on your heads whilst eating a polar mint? No. Unicycling, advanced unicycling over very narrow and deep gorges? No. What do we want you to be able to do in these answers? I want to see some evidence of critical thinking. Okay, what do you think I mean by critical thinking? For example, related to the play concept, if you can quote a few different definitions of what a play is, critical thinking would be you saying, but this one is best because X, Y, Z. Right? So making some argument that says some things are better than others based on some logical reasoning. That would be an example of critical thinking. So, probably the most useful definition of play is that it is an idea in a geologist's or an explorer's mind about how elements of a petroleum system can come together to generate and preserve hydrocarbons. So it's a play concept. Okay? If you have an idea about how the different elements of a petroleum system can come together in order to generate and preserve hydrocarbons, you can use that idea to explore in the area that you're working and say, is that what has happened here? Okay? Now, ultimately, that will lead you probably to identifying prospects, but that's quite a way further down the workflow. The play concept is the first thing that the idea that you develop that gives you a clue how you're going to deal with the basin, what you're going to look for, basically. Okay? So does that make sense? There are some things in geoscience that are not well defined. That can be a pain when you're trying to revise them. However, it's also an opportunity because it gives you a chance to say what you think critically is good and bad. Okay? Anything else? No?
Good.
Super. If you have any other questions, you can always email me and I'll try and write you a quick answer. I'm in all next week, so if you've got questions next week, when's your exam now? The 9th of May, so it's way off yet, isn't it?